According to the National Electrical Code, specifically Article 500, all electrical equipment situated in hazardous locations must be listed and approved explicitly for use in such environments. This implies that the equipment has undergone rigorous testing and certification processes to ensure it can operate safely without posing an ignition hazard. Furthermore, the National Electrical Code mandates that all conductors and equipment within hazardous locations be adequately protected from physical damage. This protection can involve measures such as using conduit, encasing equipment in protective housings, and ensuring that all components are securely mounted and supported to prevent damage from vibration or impact. Now let's look at disconnecting means. National Electrical Code 501.30 mandates that disconnecting means be provided at each entrance point to a hazardous location. This requirement aims to provide a readily accessible way to de-energize all electrical circuits within the hazardous area in case of an emergency or for maintenance purposes. The disconnecting means must meet several criteria. Firstly, it must be capable of disconnecting all ungrounded conductors of the circuit. This ensures that all potential sources of electrical power to the hazardous location can be safely isolated. Secondly, the disconnecting means must be located outside the hazardous location. This placement ensures that personnel can safely disconnect the power supply without entering the hazardous area, minimizing the risk of exposure to potential hazards. Thirdly, it needs to be readily accessible. The disconnecting means must be easily accessible to authorized personnel at all times. This accessibility ensures a swift response during emergencies or maintenance procedures. Fourthly, it must be lockable in the open position. The ability to lock the disconnecting means in the open position prevents accidental re-energization of the circuit while maintenance or repairs are being performed, enhancing safety for personnel working within the hazardous location. Now, what about additional disconnects at equipment? National Electrical Code 501.30 does not explicitly require additional disconnecting means at individual equipment within a hazardous location. However, there are some exceptions to this general rule. Let's explore these exceptions in detail. One exception is intrinsically safe systems. Equipment that is intrinsically safe does not require additional disconnecting means. Intrinsically safe equipment is designed and constructed in a way that it cannot release enough electrical or thermal energy to cause ignition of flammable materials, even under abnormal operating conditions. As a result, additional disconnecting means are not necessary to ensure safety. Another is bonding jumpers. Bonding jumpers that connect equipment to a common grounding system do not require additional disconnecting means. Bonding jumpers are used to create an electrically conductive path between different pieces of equipment, ensuring that they are all at the same electrical potential. This bonding helps to prevent the buildup of static electricity or stray currents that could pose an ignition hazard. Since the bonding jumpers themselves do not introduce a source of ignition, additional disconnecting means are not required. Circuits over 600 volts require additional disconnecting means at the equipment if the disconnecting means at the entrance to the hazardous location is not visible or accessible. High voltage circuits pose a greater risk of electrical shock and ignition, so additional safety measures are necessary. If the main disconnecting means at the entrance to the hazardous location is not visible or easily accessible from the equipment, additional disconnecting means must be provided at the equipment itself. This ensures that personnel working on the equipment can quickly and safely de-energize the circuit, even if they cannot reach the main disconnecting means. Now, let's consider jurisdictional authority. Ultimately, the requirements for additional disconnecting means in hazardous locations may vary depending on the jurisdiction. Local inspectors may have different interpretations of the National Electrical Code or may have adopted additional requirements. It is important to note that the National Electrical Code serves as a guideline, but local authorities have the final say in interpreting and enforcing these regulations. Therefore, it is essential to consult with the local electrical inspector to ensure compliance with all applicable requirements. Based on this case, it is recommended that the customer consult with the local electrical inspector to determine if additional disconnecting means at each unit inside the trailer are required. Local inspectors can provide valuable insights into the specific requirements in the area and can help ensure compliance with all applicable regulations. Providing additional disconnecting means will ensure compliance with the National Electrical Code and help to reduce the risk of electrical hazards in hazardous locations. By installing additional disconnecting means at each unit inside the trailer, the customer can provide an extra layer of safety and protection for personnel working in a hazardous area. This proactive approach demonstrates a commitment to safety and helps to minimize the risk of accidents or injuries. Electrical safety in hazardous locations is paramount to protect personnel, equipment, and the environment from potential hazards. Hazardous locations are areas where flammable gases, vapors, dust, or fibers are present, creating a risk of fire or explosion. These locations require special precautions to prevent ignition of flammable materials and to ensure the safety of workers and equipment. Firstly, it is essential to identify and classify hazardous locations correctly. Hazardous locations are classified based on the type of hazardous material present, its concentration, and the likelihood of its presence. The National Electrical Code defines different classes, divisions, and groups of hazardous locations to provide guidance on the appropriate electrical equipment and wiring methods for each location. Secondly, use only listed and approved equipment in hazardous locations. All electrical equipment used in hazardous locations must be listed and approved by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This ensures that the equipment has been tested and certified to meet the safety requirements for use in hazardous environments. Listed and approved equipment is designed and constructed to prevent ignition of flammable materials and to minimize the risk of electrical shock or other hazards. Thirdly, install wiring and equipment according to the National Electrical Code. The National Electrical Code provides detailed requirements for the installation of wiring and equipment in hazardous locations. These requirements cover a wide range of topics, including wiring methods, grounding, bonding, sealing, and ventilation. Following the National Electrical Code ensures that electrical systems are installed safely and that the risk of ignition or electrical hazards is minimized. Fourthly, implement proper grounding and bonding techniques. Grounding and bonding are essential for electrical safety in all locations, but they are particularly important in hazardous locations. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, preventing the buildup of static electricity or stray currents that could pose an ignition hazard. Fifthly, seal all conduit and equipment enclosures. Sealing is used to prevent the passage of flammable gases, vapors, dust, or fibers into electrical equipment enclosures. Sealing is typically accomplished by using sealing fittings and compounds that create a gas-tight or dust-tight barrier. Sealing is essential to prevent the accumulation of flammable materials inside electrical equipment, which could lead to an explosion or fire. Sixthly, provide adequate ventilation. Ventilation is used to dilute and remove flammable gases, vapors, dust, or fibers from hazardous locations. Adequate ventilation can help to prevent the buildup of flammable materials to dangerous concentrations. Ventilation systems should be designed and installed in accordance with industry standards and best practices. Seventhly, implement regular inspection and maintenance programs. Regular inspection and maintenance are essential to ensure that electrical equipment and systems in hazardous locations are operating safely and effectively. Inspections should be conducted by qualified personnel who are familiar with the requirements for hazardous locations. Maintenance should be performed on a regular basis to prevent equipment failures and to ensure that all safety features are functioning properly. Eighthly, train personnel on electrical safety in hazardous locations. Training is essential to ensure that personnel working in hazardous locations are aware of the potential hazards and are trained to work safely. Training should cover topics such as hazard recognition, safe work practices, the use of personal protective equipment, and emergency procedures. Properly trained personnel are more likely to identify and avoid potential hazards, and they are better prepared to respond to emergencies. The importance of consulting with local authorities should not be overlooked. Local authorities, such as electrical inspectors and fire marshals, have the authority to interpret and enforce the National Electrical Code and other applicable regulations. Consulting with local authorities can help to ensure that electrical systems in hazardous locations are installed and maintained in compliance with all applicable requirements. In summary, electrical safety in hazardous locations requires a comprehensive approach that includes hazard identification, equipment selection, installation practices, grounding and bonding, sealing, ventilation, inspection and maintenance training, and consultation with local authorities. By implementing these measures, it is possible to minimize the risk of electrical hazards and to protect personnel, equipment, and the environment from potential harm. Furthermore, the NEC requirements for disconnecting means serve as a critical safeguard in hazardous locations, providing a means to quickly and safely de-energize electrical circuits in emergency situations or during maintenance procedures. Understanding these requirements, along with the exceptions and recommendations, is essential for ensuring compliance with electrical codes and promoting a safe working environment. By consulting with local electrical inspectors and implementing appropriate disconnecting means, businesses can mitigate the risk of electrical hazards and protect their personnel and assets. In addition to the specific requirements outlined in the NEC, there are several other best practices that can enhance electrical safety in hazardous locations. Firstly, develop and implement a comprehensive electrical safety program. An electrical safety program should outline the policies, procedures, and practices that are in place to protect workers from electrical hazards. The program should include elements such as hazard assessment, training, personal protective equipment, lockout/tagout procedures, and emergency response plans. Secondly, conduct regular hazard assessments. Hazard assessment should be conducted on a regular basis to identify potential electrical hazards in the workplace. The assessment should consider factors such as the presence of flammable materials, the condition of electrical equipment, and the work practices of employees. Thirdly, provide employees with appropriate personal protective equipment. Personal protective equipment, such as arc-rated clothing, gloves, and face shields, can protect workers from electrical shock, arc flash, and other electrical hazards. Employees should be trained on the proper use and care of personal protective equipment. Fourthly, implement lockout/tagout procedures. Lockout/tagout procedures are used to prevent the accidental energization of electrical equipment during maintenance or repair work. These procedures involve disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Fifthly, develop and implement emergency response plans. Emergency response plans should be in place to address electrical emergencies, such as fires, explosions, and electrical shocks. The plan should include procedures for evacuating the area, contacting emergency services, and providing first aid to injured workers. Sixthly, maintain accurate records. Accurate records should be maintained of all electrical inspections, maintenance, and repairs. These records can be used to track the condition of electrical equipment and to identify potential problems before they lead to accidents. Seventhly, stay up to date on changes to the NEC and other applicable regulations. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. Local authorities may also adopt additional regulations, so it is important to be aware of these requirements as well. By following these best practices, businesses can create a safer working environment for their employees and reduce the risk of electrical accidents in hazardous locations. Remember, electrical safety is everyone's responsibility, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Now let us talk about some specifics of compliance. Compliance with the National Electrical Code in hazardous locations is not just a matter of following rules. It is about ensuring the safety of personnel and preventing catastrophic events. To achieve this, a systematic approach that integrates planning, execution, and continuous improvement is essential. Firstly, start with a thorough hazard assessment. Before any electrical work begins, conduct a comprehensive hazard assessment to identify the types and concentrations of hazardous materials present. This assessment will determine the classification of the hazardous location, which will dictate the specific requirements of the National Electrical Code that must be followed. Secondly, select appropriate equipment. Choose electrical equipment that is specifically designed and approved for use in the identified hazardous location. This equipment will be marked with the appropriate classification and will be constructed to prevent ignition of flammable materials. Thirdly, install wiring and equipment correctly. Follow the National Electrical Code guidelines for wiring methods, grounding, bonding, and sealing. Ensure that all connections are tight and secure and that all equipment is properly supported and protected from physical damage. Fourthly, implement a robust inspection and maintenance program. Regularly inspect electrical equipment and wiring for signs of damage, wear, or corrosion. Perform preventative maintenance on a scheduled basis to keep equipment in good working order. Fifthly, train personnel thoroughly. Provide comprehensive training to all personnel who work in or around hazardous locations. Training should cover the hazards present, the safe work practices that must be followed, the use of personal protective equipment, and the emergency procedures that must be followed in the event of an accident. Sixthly, document everything. Maintain detailed records of all hazard assessments, equipment selection, installation, inspection, maintenance, and training activities. These records will be invaluable in demonstrating compliance with the National Electrical Code and in identifying areas for improvement. Seventhly, stay informed and adapt. The National Electrical Code is constantly evolving, and it is important to stay informed of the latest changes. Also, be prepared to adapt your electrical safety program as new hazards are identified or as the nature of the hazardous location changes. Remember, compliance with the National Electrical Code is an ongoing process, not a one-time event. By following these steps and by fostering a culture of safety in the workplace, you can create a safe and productive environment for your employees and prevent costly accidents.